A few more examples of how to solve equations involving logarithms. So here we have a problem and it has all kinds of pieces and parts to it. And as I continuously say, nothing really changes. You can still move your basic terms. So in this problem, this -3 here, there is nothing preventing me from moving it to the other side of the equation. I can write 1/3 log base 2 of tiger equals -1 plus 3, so when I add 3 to that, I get 2. Now my next step, I can deal with this multiplication. It says 1/3 times the log, so I can get rid of it through regular multiplication. I can just multiply by 3. Fraction disappears. I get log base 2 of tiger equals 3 times 2 is 6. And then I get down to this point where it's nothing more than just a exponential problem. I can write this in exponential form. 2 to the 6th is equal to t. And so I don't need a calculator for that. That's going to be 64. 64 is equal to tiger. 2 to the 6th power is 64. Off of this problem, maybe you don't see to multiply by the 1/3 and that you want to call that t to the 1/3. You could do that as well. So just an alternate approach right here. Maybe I take this 1/3 and use my properties of logarithms and say that I have log base 2 t to the 1/3 equaling 2. Then I could say, if I go to my exponent form, 2 to the 2nd is equal to t to the 1/3. But that's going to be 4 is equal, because 2 squared is 4, equals t to the 1/3. And then I could cube both sides. And 4 times 4 is 16. 16 times 4 is 64. I'll get the same result regardless of how I solve that. And so then I showed 2 different ways to do the same problem there. I have an example 15. It says log of frog, log of f, plus log of 7 equals 3 log 5. And you'll see that some of these questions are just testing your understanding of the properties of logarithms. First off, I can move this log to the other side. It's just a number. So I can say log of frog is equal to 3 log 5 minus log 7. Log of frog is equal to, now if I'm using my rules of exponents like I did in the last example, I can say that this is 5 to the 3rd power. And 5 to the 3rd power I know to be 125. And if you remember, when you are subtracting logs with the same bases, this is considered base 10, you are allowed to condense those expressions, and subtraction is implying division. So I could say this is log of frog is equal to log of 125 divided by 7. Which means, if these are the same logs, same bases, f would have to equal 125 over 7. And I did that without a calculator. That was all just knowing the properties and identities of logarithms. I've got one last example I would like to go through. I have it up here. Example 16. There's a problem really similar to this in the homework. I thought, oh, this is kind of fun to go through, so I wanted to make sure you had every chance of success on this. It says log base 3 of x plus log base 3 of x minus 6 is equal to 3. Using our properties of logarithms, when I'm adding, it tells me that I can multiply those arguments. And so I'm going to condense this by saying log base 3 of x times x minus 6 is equal to 3. I'm going to go ahead and distribute that here. So log base 3 of x squared minus 6x is equal to 3. And then from this step, I can go to that exponential form. I can say that 3, the base raised to this exponent, 3 to the third must be equal to x squared minus 6x. And 3 to the third is 27. Go back to your algebra days. This looks like a problem that if I move the 27 over, I could factor. If I AC it, I have an AC of negative 27, a B value of negative 6. I could create that with negative 9 times 3. Negative 9 times 3 is negative 27. Negative 9 plus 3 is negative 6, which means that this factors into x minus 9, x plus 3, and I've got two cases. Case 1, x is 9. Case 2, x is negative 3. And you can check to see which or if both of those work. You don't need me to do that, but I show you the math, the algebra on how to come up with an answer. And so now you've got 16 total examples to look off of as you attempt your next homework.